Remember, when you're finding the inverse cosine, you have to look only between 0 and pi, right? Or 0 and 180. Okay? We are only doing the top part of the unit circle.
So sine, you use the bottom?
Nope, sine you use the right half.
Are you kidding?
Yep. Okay? Sine, we're only looking at the right half. Cosine, we're looking at the top half. All right? So sine is between negative pi over 2 and pi over 2. Yep, sine would be in quadrant 1 and 4.
What?
In the quadrant 1 and 4. Cosine is in quadrant 1 and 2. Right? So you can read sine to the negative 1 as the number whose sine is
Wait, what side do you use for sine?
sine. You're using the right half of the circle. Okay. The notation arcsine is sometimes used in place of sine to the negative 1. If you ever see an arcsine, that means the same thing as this. Okay? Now, just like cosine, when you're looking at the domain and range of the function and its inverse, they're switched. Okay? Thus, the domain of sine to the negative 1 is negative 1 less than or equal to x less than or equal to 1. Okay? Or you could look at, and the range is negative pi over 2 less than or equal to y less than or equal to pi over 2. You could put these in degrees also. Okay?
When will we ever test that?
In a little while. Some inverse sine values can be found exactly without a calculator. So let's look at this first example. We have evaluate the inverse sine of negative square root of 3 over 2 without a calculator. So what you're wanting to do with that is to pull out your handy dandy unit circle. Look for the y value of negative square root of 3 over 2. What degree is that on? Negative square root of 3 over 2 is where? At 300, right? Or 5 pi over 3. Okay, so it's at negative 300 or 5 pi over 3. The other way you could look at it is at a negative pi over 3. Because it's going down, right? So it's the y value we're looking at. You use your unit circle and work your way backwards. Because, okay, if you look at the unit circle, the y value up here is always positive, right? So we can't use this quadrant. We have to use this quadrant then. Because we're looking at a negative square root of 3 over 2. So if you look on this quadrant, when you find the negative square root of 3 over 2 as the y value, okay, that is at 300.
I don't really know what it's at.
Okay? This is negative 1/2 on the unit circle.
That'd be 270. And it's gone.
It's at 330 degrees, correct? Oops. It's at positive 330 degrees or negative 30 degrees, right? Those two things are the same thing, right? So if we're starting here, we go all the way around, 330 is right here. No, it has to be.
Since it's negative, wouldn't it have to put it negative? Because that's what we're doing.
If I said negative 330 from here, I'm actually going to end up here.
After 0 through 30.
Yep, so should be 330 right here. Or I could say negative 330. Negative 30, I mean. No, it has to be in the right two quadrants. Okay? That is also considered negative pi over 6. Or I could say that is 11 pi over 6, right?
Oh.
Weird. Okay.
Oh, sorry, I totally too much.
Okay? Now, these ones are a lot easier because all you have to do is punch them in your calculator. Okay? So on this one, you're actually going to put into your calculator sine to the negative 1 power 0.7214. Yep.
How do you know you're doing inverse sine?
Usually on your calculator,
No, I mean, how did you know how to do it?
because it starts off like this, and I'm solving for theta. So it's like if I had 2x, I'm dividing both sides by 2 to inverse it, right? So we're inversing the 2 in this case. This first one, we have to get rid of that sine somehow to get theta by itself. And in order to do that, we're doing the inverse of sine.
Oh, okay.
Okay? So when you do that, you should get an estimate of 46.2 degrees. Okay, the second one, same thing. Sine of negative 1 to the 0.2616. What did you guys get for that one? 15.2? Okay. All right. So let's keep going here. Recall from chapter 3 that f and f to the negative 1 are inverse functions. Okay, if you take the composite of f and f to the negative 1, that answer is always just x by itself. Okay? Same thing as going f to the negative 1 and f. That's just reversing these two. This still stays the same as x. So the same thing can be said for sine of sine to the negative 1 of x. That equals x. For all x in a domain of sine to the negative 1. And I could reverse that. I could have the inverse first. For all x in the restricted domain of sine of x.
And what's the restricted domain?
The restricted domain is always in that right half, from negative.
Positive 1 to 4.
Yeah, yeah. Jack.
Didn't you say you had to have the parentheses separating x from sine or theta?
You can, yeah. I don't know. You can still have parentheses there. It's still the same thing.
I thought it came out with a different answer.
No.
So there should be other parentheses around that.
Yeah, you can. Actually, the book, for some reason, doesn't put it in there. It's not hurting it, but. All right, let's go on. Explain why sine to the negative 1, parenthesis, sine 5 pi over 4 does not equal 5 pi over 4.
It equals 4 over. It equals.
Why does it not work for this?
Because
Because
sine is
sine
in
is
the
pi.
void. It's
Isn't
not
taking
by
the
itself.
sine of 5 pi, not 5 pi over 4?
Well, yeah, I would have liked for them to write it like this instead, but even if it were written like this,
Oh, is that what it is for them?
yeah, that's what they're saying. Why doesn't this equal this?
What? It doesn't?
No.
But it didn't in
Oh,
our
no,
normal.
because that's cosine.
Because, so?
Yeah, I don't know.
Think about it for a second.
There's only 56.
I am. I stop thinking.
What is our restricted domain?
Oh, it's only the half. And so that's not on that half of the. Okay, got it.
Okay, it's not in our restricted domain. So, to do this one,
Can we use our unit circle on the first
yeah, I'll let you use it tomorrow. Okay? That's the main reason. This is not in the restricted domain. If I wanted to find an equivalent to that in the restricted domain, what would it be? It would be 7 pi over 4, right? Because that's in the fourth quadrant.
Why is that?
Because 5 pi over 4 is in the third quadrant. And you need to make sure that the sign of that is in the same value range. So,
What is it? How do you know what it has to reflect in?
okay, so look. 5 pi over 4 is like over here, right? Now, sine is the y value, right? So it's going to have to be negative. So the other one that would give me an equivalent sign would be the one over here.
Why does it have to be?
Because this value right here would be a negative sign.
But why does I don't understand why it makes it equivalent?
The sign right here, if you look at your unit circle, is negative square root of 2 over 2, right? If you look at the sign over here, it's still negative square root of 2 over 2. They're the same value. Because you're looking at the distance from here to here and the distance from here to here. They're the same. Okay, so if we did that, then the answer would be 7 pi over 4. Okay, because it's inside the restricted domain. But the other one is not. Okay, so example 3b. For what value of theta between 0 and 180 is it the case that sine negative 1 sine theta is not equal to theta? Okay, so now look at your, thank you. Look at your unit circle, and it's saying in,
90 to.
yes, right here, in this range, right here, it does not equal it, right? Because that's outside the restricted domain. So anything between 90 degrees, good job, theta less than 180, would be what doesn't work. If you actually tried the inverse sine of these numbers on your calculator, you get a syntax error.
Really?
Mm-hmm.
Why?
It just doesn't work because it's outside the restricted domain.
But like, why is there restricted domain?
Good question. I don't know if I can answer that for you right now. Okay, I'll try to look into that and try to find an easy way to describe it to you later. But okay, applying the inverse sine function. The inverse sine function has the applications in all situations involving the sine function, but most of the time we use it to find a missing angle. Okay, so here's the example. We have an 18-foot ladder leaning against the building, and we want to find what h is. That's the height from here to here on the building. Or actually, we're wanting to find theta, but we want to do that by solving using the letter h. Okay, so we know that sine in SOHCAHTOA is opposite over hypotenuse, right? That being the case, so we have sine, oh, that's a terrible S, equals to h over 18. I need to get rid of that sign so I can solve for theta by itself. So how do I get rid of the sign? Yeah, or you would typically divide, but in this case we're going to take the inverse sign.
It'd be like the same thing though, right?
Well, kind of. Sine's kind of funny this way. If it were a 2 theta, you would divide by 2. But this is a sine theta, so you're going to inverse sine. Yes. Okay? So this would be our formula. It says pick 3 possible values of h and find 3 corresponding values of theta. So I'm just going to pick 3. let's just try when h equals 16, when h equals 15, and when h equals 13. Okay, somebody said when h equals 21. Why can't it not be 21? 21 is bigger than 18. So if I were to prop this up against the wall, 21 would be how many feet taller than the ladder? Yeah, it would be 3 feet taller than the ladder itself. So that would not work. Okay, so if I put this in and find this inverse sine, I would do 16 over 18 with the inverse sine. What do you get for that? Because I'm trying to find what the angle would be if I had a 16-foot height. Do the same thing for 15 and the same thing for 13. So if you plug those in your calculator, what do you guys get? Oh, this should be a 13. Your calculator's not working? Okay, I'll look at it. Yep, 62.7 is the first one. Might have to. If it's in radians, it won't work. Yep, I have 0.3. That's close. What did you get for the last one? Good, 46.2. All right. So those are our 3 corresponding degrees. So depending on the height. Now, the last thing I wanted to say is, what are our possible values of h? What's the smallest h we can have? What? That's the largest h we can have. So, okay. Even smaller than that. 0. Okay? That's our actual values of h that we can use. If we were looking at theta, what are our possible values of theta? Well, the largest value of theta we can have is 90 degrees, right? Where it's straight up and down. And the smallest value of theta is 0 degrees. All right?